In this lesson, we'll be looking at what's called the triangle inequalities, or triangle inequality theorem. A couple of things in this one. You'll be able to determine if a triangle can be constructed when given the three side lengths. In other words, can you make a triangle out of any three pieces of wood or three pieces of thing, no matter what their lengths are? And the answer is no. We'll see how we determine that. In addition, you'll be able to list the sides of a triangle in order from greatest to least or least to greatest when you're given the angle measures or vice versa. We'll see how those work. Pretty easy stuff. So first of all, in the triangle inequality, it says in order for a triangle to be constructed or made, the sum of the lengths of the two smaller sides must be greater than the length of the larger side. So when we add up the two small ones, it has to be greater than the largest side. An added note, in an isosceles triangle, the sum of the length of the legs must be greater than the length of the base. So just to look at the smaller sides, you can see this we're trying to make a triangle out of these three lengths right here. But you can see these two smaller sides are not greater than this side, really, and we can't make a triangle out of them. We bend this one over, you'd have to stretch it out larger to meet it. So yes, if these lengths aren't, when you add them up, greater than this side, you can't make a triangle. Even if they're equal to it, they end up, just laying down on top. So it has to be greater than, a little bit bigger than, like this, and you'd be able to make a triangle out of it. Okay, strictly greater than, not equal to. So let's see how that works. So we got a couple right here. Here's three side lengths. It says determine if the following sides can make a triangle. If yes, then classify by sides. So we'll do a little of that. I forgot about that one, but we'll do it. So the two smaller sides are 8 and 9, and 8 and 9, 8 plus 9 makes 17. Let me get a pen here. So if we add these two up, we get 17, and the third side is 10. And yes, the sum of these two sides is greater than this larger side. So yes, we can make a triangle out of it. Now when the side lengths are all different, that is called scalene. So the classification is scalene. S-C-A-L-E-N-E. Alrighty. The next one, the two small sides are 1 and 1. So 1 plus 1 is 2. And the third side, the biggest side, is 2. And that's equal to each other. And no, it's got to be greater than. So this answer is no. You can't make a triangle out of side lengths 1, 1, and 2. All right, our next one, 6 plus 6 is 12. The two smaller sides add up to 12. The third side is 10. And yes, those add up and are greater than that third side. So yes, you can. Two sides are the same, so this is an isosceles. Triangle by classification. And then 4, 4, 4, let's see. They're all the same, right? So you can take any two, add them up, and it should be greater than the third side. So yes, these two added up are 8. Is it greater than the third side, which is 4? Yes, it is. So yes, we can make a triangle. What is this triangle with all the sides the same called? Equilateral. So there's a reminder of your three classifications. Later you'll do them on paper. You're not going to put them on the computer. You're just going to tell me yes or no. But equilateral when they're all the same. Isosceles when two sides are the same. When they're all different, it's called scalene. Add up the two smaller ones, has to be bigger than the largest side. Not equal to, but bigger, greater than. Next example. Next thing, in a triangle, the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. I drew two sides of a triangle right here. Right now you can see this third side would go from here to here. What happens when I make this angle right here smaller? Well, this third side becomes smaller. That's why they're saying opposite the smallest angle will be the smallest side, and so forth. If I make this angle bigger, the side opposite, which goes from here to here, would become bigger. And that's why it works that way. Opposite the biggest angle would be the biggest side. If I make it even bigger, that side becomes huge. Okay, now this would be the biggest angle in here, and this would be the biggest side. We'll see how that works here. We get a little bit more. So when you're given the angles, you can tell me what the largest side is here. You know, the largest angle right here is A. This angle right here. I'll make a little mark there. It's 120 degrees. That's the biggest angle. So opposite it is this side right here. Yes, when this angle opens up, this side gets bigger, whatever. It is the biggest angle, so this is the biggest side right here, side BC. Then to find the smallest side, you find the smallest angle. Well, the smallest angle right here is C at 20 degrees. So then we go find the side opposite it. Well, opposite this angle, it's this side. It basically uses the other two letters. If I'm looking for the side opposite C, well, it's A and B. So since C is the smallest angle, side AB will be the smallest side. It's that simple. And in a minute we do the same thing when we're given sides and want to know which one's the biggest angle. Example 3, classify the triangle by its sides and then list the angles from least to greatest. So I can see all the sides are different. That is a scalene triangle. Then now you got to pay attention to what they want. This one they want least, which is the smallest, to the greatest. Sometimes they do it from greatest to least. But they want the least first, the smallest angle. So I look for the smallest side, which is this one right here, is 9. So which angle is opposite it? This one right here. Again, the side is called AC, so the angle opposite it would have the other letter, B, or you can draw the picture there. Okay, opposite this side is that angle B. This was the smallest side, so that's the smallest angle. Angle B. What comes next? The medium one. So the medium side is this side AB. So opposite it would be over here, angle C, the other letter. You can draw the arrow if you want. Here's the medium side right here. Whoops, a little messy here. So opposite this side is this angle right here. So angle C would be the next largest. And then the largest one, let me clean up my mess here. Well, we can see the largest side is 15 over here. This side CB. So that means angle A would be the largest angle. That's simple, you know. If you have any questions, you can stop the video and ask me, but that's how it works. Opposite the biggest angle is the biggest side. Opposite the biggest side is the biggest angle, and so forth. Here we've got one, read this whole problem. List the sides of triangle ABC in order from longest to shortest. If the angles of triangle ABC have the indicated measures. So the measure of angle A is 10x, the measure of angle B is 5x, the measure of angle C is 7x minus 1. So we need to solve for x, and then once we know x, we can plug it in here and find the actual measures of all these three angles. Then we can see which is the biggest angle and know which is the biggest side, and so forth. So we know that all the angles in a triangle have to add up to 180. So let's see, angle A is 10x, plus angle B is 5x minus 17, plus angle C here is 7x minus 1. So we'll go ahead and combine like terms. All the x's make, let's see, 10 plus 5 plus 7 is 22x, and then the minus 17 and the minus 1 make minus 18. So we'll go ahead and add 18 to both sides to get rid of this minus 18. And we get 22x equals 198. Our last step will be to divide to get x. And we get x equals 9. Okay. Now we can plug that number in for x right here. So measure of angle A is 10x, so that's 10 times 9, which is 90 degrees. Measure of angle B is 5x minus 17, so 5 times the x number 9 minus 17. Put that in your calculator, you should get 28. Let me know if I make a mistake. And then the last ones, so we got 7 times 9 minus 1 here, and we get 62. I did double check and added all those up, and they did add up to 180. So now I know the biggest angle is, we want from longest to shortest now. So we'll start with the biggest one. So the biggest angle is 90 degrees, which is A right here. Opposite A over here is side BC. So that's the biggest side. Then next, the medium angle here is C. So here's angle C. Opposite angle C is side AB. So to figure out the sides, we had to know the angles. And then, of course, the smallest angle, 28 degrees, is angle B up here at the top. The side opposite it would be AC. Not too bad. Just pause the video whenever you need to. I'm going to go to the next example now. This one you got to do a little more thinking. It says in triangle RST, which is a possible side length for ST over here. So I'll put a little question mark here. So one of these, or not, can't be determined, is a possible. It doesn't mean it is a side length, but is possible. So the only thing they give us are these two angles right here. So I really need to know the measure of this third angle. So we set up an equation for that, so we can figure out how much this one is. We know they all add up to 180. So this is angle R, so measure of angle R plus the other two angles have to equal 180. We add those two numbers together, we get 121. So we subtract the 121 to get the measure of angle R by itself, and that is 59 degrees. So this is the smallest angle. This should be the smallest side over here. And I can only see one side here, right here, is 8. So, I'm sorry, I messed up. This is not the smallest angle. This is the smallest angle. So the 8 should be the smallest side. That means it can't be 7. It can't even be equal to it because the angles aren't equal to 8. So one possible answer is yes, it is possible for this side to be 9. Again, I started messing up. Here's the smallest angle, so this should be the smallest side. That's why it can't be 7, because this is going to be the medium side actually. It can't be even equal to it, but it can be 9. It can be bigger than this one. Very good. So there's your lesson. Next you're going to work on the practice and put your answers in online. Have a good day.